Hi and Assalamualaikum warahmatullahi ta'ala wabarakatuh. So I am ISKANDAR bin HAIRULNIZAM and I with AHMAD Amin Firdaus. So today I will explain to you about lab 1, which is a 7-segment counter. In this lab, we need to design the clock divider to create type of frequency in order to count in different speed, which is in this lab there are 6 steps that we need to program. First is divide 10 and then divide 50, and then we go to program the clock gen. In clock gen we need to include divide 10 and divide 50. Then the next program is clock counter and SAKRI. Okay, at the last step is we need to program the clock account 0099, which is need to be included all the 5 programs that we have done before this. Alright, in this lab, we are required to design a counter using a 7-segment on the DE2115 development board. So as a given in the descriptions, the step-by-step procedure must be followed to create a counter that runs in a different speed. A clock divider must be created to design a variety type of frequency. For the first step, this experiment instructs us to design the divide 10 as given in the description. So this is a divide 10 reporting of compilation without error. And then this is also the divide 50 compilation without error. And then the third step is we can get the clock gen compilation without error. So if there are any error, we need to edit the coding following the step have been given in the lab manual. So the next result is which is the compilations of clock counter and the SAKRI program without error. So finally, count 009 need to be designed before the program and upload into the DE2115 board. And then we also need to assign the pin by referring to the manual have been given in the lab manual. So we can look at this count 0099 also no error, and then if there are no error, we can just upload it to the board. So finally, the output of the program can be observed on the DE2115 development board. So the 7th segment is showing the output result of the counter that runs with different frequency as created in the program description using the Quarters 2 software. So we can look at the output at the 7th segment. Okay, now we go to discussion part, which is the first question is to implement the counter at a high and low frequency clock and show the output and in the 7th segment. So when we are using the high frequency clock, the output of the counter clock will change at a fast rate, and the value on the 7th segment change at a fast rate depending on the frequency value have been assigned. While at low frequency, the output speed is become slower and counter and on 009 at the 7th segment change with the low speed depending on the value. The speed of output of counter clock show the slower speed at a low frequency clock. So as a result, a high frequency clock produce a high counter speed, while the low frequency clock produce a clock counter speed by adjusting the changing value of the clock input. So we can see at the video, which is the number becomes slower with a low frequency. Okay, so the next question is to explain why component instantiations and process statement are used in count 0099. So a statement that connect the element in a circuit is called component instantiations. As a result, it is used in count 099 to connect all the elements that it contains from the smallest to the largest. And as the result, all the elements that have already been declared can be connected to form a complete circuit, while the process statement is used to ensure that the count 0099 can run all the process at the same time. So the last question is to explain the process statement in SAKRI and clock counter. Behavioral style combination design is implemented in the clock counter and SAKRI codes. The case statement is used in SAKRI process statement, while if statement is used in the clock counter. Theoretically, case and if statement are similar in they allow the user to choose between alternative sequence of sequential statement to be executed. So, if statement is used in the clock counter process statement to select one of none of the alternative execution sequences. The conditional executions of other sequential statement is controlled by if statement. The if statement can also be nested. Lastly, in the case statement used in SAKRI process, because only single expressions is chosen for execution. Furthermore, the case statement lists alternative start with reserved word when and follow other sequences. If the other alternative do not handle other possible value of the case expressions, this statement will mostly like end with other. The reserved word when and follow the other sequences if the other alternative do not handle other possible value of case expressions. This statement will most likely end with other. So as the conclusion, in this lab, student can learn how the Fpga learning on the Fpga development board and software that is compatible with them, because some error occur during the code compilation because of poorly managed folder creations and resulting in the result that were not expected. So what we get in this lab is we can understand the basic design flow by using the DE2115 board and Quartus2 software, and then we're also able to design a simple full adder with VHDL, schematic block diagram and waveform. And then lastly, we can design a counter with frequency divider using the 7 segment on the DE2115 board. So I think that's all from us. Thank you.
Hi, my name is AHMAD Amin Firdaus bin SAKRI. Today, I would like to present to you the result that we get from the previous lab session with my partner HAIRUL ISKANDAR bin HAIRULNIZAM. Okay, before we go through the result, I want to give a simple explanation about the lab that we have done. We play around with the LCD, which is an electronic component with a flat panel display made of liquid crystal sandwiched between two sheets of glass. The objective of this lab is to use the LCD display on DE2115 Fpga board for VHDL display program 16x2 module, and to modify the program with a different display output. In this lab, we use Altera Quartus2 software to run a set of programs to display dates in English and Malay. The dates has been displayed on the LCD screen in the Altera DE2115 board. Okay, this is HD44780 char data head values used to display words on the LCD screen. All of the words displayed on the LCD screen is a combination of this code corresponding to each of the characters. Okay, now let's see the result from our lab session. For the first, LCD screen display Monday and Isnin correctly correspond to the bit 0000. The words Monday is the combination of the char data hex value of this line, and Isnin, to produce Isnin, we use this code to represent each word in the Isnin. Next, For Tuesday, LCD screen display Tuesday and Selasa correctly correspond to the bit 0001. To produce word Tuesday, this is the corresponding words and line, and this is the combination of data hex value to represent Selasa. For Wednesday and Rabu, LCD screen correctly display in both of the language correspond to the bit 0010. To produce Wednesday, this is the combination char data hex value, and this is the combination char data hex value for display Rabu. Okay, to display Thursday, correspond to the bit 0011. This is the corresponding char data hex combination to display Thursday, and this is the combination to display Khamis. Okay, for the next result, the LCD screen display Friday and Jumaat correspond to the bit 0100. Char data hex combination for Friday is like this line, and char data hex combination for display Jumaat is this line. Okay, this is the result that we got to display Saturday and Sabtu correspond to the bit 0101. To display Saturday, this line need to be written, and to display Sabtu, this is the corresponding combination of the char data hex value. Next, for Sunday and Ahad, the corresponding bit is 0110. To produce the word Sunday, this is the line, and to produce Ahad on the LCD screen, this is the line. Okay, for the last result of the lab session, the LCD screen display VBT controller correctly correspond to the other bits from 000 until 0110. The combination of the words VBT produced by this line and controller 00 is produced by run this line of code. Next. Okay, we go through the discussion. For the discussion, we need to modify the design that show January to December when switch is toggled. Okay, to achieve this task, we need to make a slightly modification to our coding. We add some of a few more condition for the 12th month, because the original coding is to display 7 days, so we need 5 more condition to display the month. Okay, this is the result from the modification of our coding. For the first, the LCD screen display January, so this is the combination char data hex value to display January and in English and Malay. Okay, the next, the LCD screen display February. This is the modified coding line to display February in English and Malay. Okay, the next result, we got March on the LCD screen. To achieve that, we use this line to display March in English and this line to display March in Malay. For the April, we got April written on the LCD display because we make some modification in this line to display April in both language. Okay, next, the LCD screen now show May because we convert the char data hex value with this coding to display May in English and Malay. For June, we got the Junes on our LCD screen display with the new modified coding line like this. Okay, for July, the LCD screen now correctly display July in English and Malay, because this is the corresponding line to display in both language. For August, this LCD screen now display August in Malay and English correctly, correspond this from this combination of child data X value. Okay, next we got September correctly in both language based on this modified coding line. Now we got October in English and Malay correctly, because this is of the combination of child data head value in Malay and English. Next, the LCD screen now display November. This is the modified coding line for display November. And lastly, to display December, we modified the coding with the combination child data head value like this and this line to produce December in English and December in Malay language. Okay, for the conclusion, each of the normal character has their own code based on HD 44780 child data head value. Condition to be set in this lab session must also be equal to the number of days and month to ensure that each day and month has its own combination binary bit to be displayed. Okay, that's all from me. Thank you.